Okay, I want to finish section or lesson 13, which will be problems 8 through 9. I also want to make a quick retraction as well, however. So on problem 7, the horizontal asymptote, and I said as much, is 1, not 8. So horizontal asymptote is 1. That's the dashed line at y equals 1. I started out accidentally writing down these features on problem 8, so evidently I had ocho on the brain. I do apologize for that. Arithmetic, I feel like it's a clerical error more than anything, but number 1, and that's the kind of thing that can sometimes trip some people up on tests, is you know the right answer, but for some reason you put the wrong answer down. So don't put the wrong answer down in life when it counts. And have the courage to admit when you're wrong. Okay, moving on to problem 8. We have the absolute value of y equals 1/2, or the absolute y equals 1/2 times the absolute value of x plus 3. I'm going to make a little table over here. I'm going to start with 0, -1, -2, -3, 1, 2, 3, 4, 5 maybe. Nah, I'm just going to go down to 3. And actually, no, for illustration purposes, I want to start at -5, -4, -3, -2, -1, 0, 1, 2, and then 3. Okay, so let's start at 0. If I plug in 0 for x, that's going to be 1/2 times absolute value of 0 plus 3. Well, 0 plus 3 is 3, and 3 times 1/2, well, that's like 3. Second, I thought this was a blue. So that's 3, or 1/2 times 3. Well, 3 times 1/2 is just 3 halves. Multiply the two numerators, and that's actually 3 over 1. You multiply the denominators, so 3 times 1 is 3, 2 times 1 is 2. 3 halves, that's like saying, well, how many times does 2 go into 3? 2 goes into 3 at least once. 2 times 1 is 2. Well, 2. 3 minus 2. There we go. 3 minus 2 is 1. Carry down the 0. 10. 2 goes into 10 times. And 2 times 5 is 10. And in decimal places, this is the tenths place. Over here is tenths place. And then the next digit over here is the hundredths place. And then the next digit is the thousandths place. So the point being that if you have 2 or 1.5, that is the same thing. 2.5 is the same thing as 2 and 5/10. And 2 and 5/10, well, 5 goes into 5 once, and 5 goes into 10 twice, is the same thing as 2 and, excuse me, as 1.5. 1.5, because we established 3 goes into 2 once. 2 goes into 3 once. So 3 halves equals, when x equals 0, y equals 3 halves, or 1.5. Either one. And then next one, when x equals 1, when x equals 1 plus 3 equals 4. The absolute value of 4 is 4. 4 times 1/2 just equals 2. And then when x equals 2, 2 plus 3, that equals 5. And this time it'd be 5 over 2. Because we're going 1/2 times 5 over 1. So that just equals 5 halves. And 5 halves is the same thing as 2.5. So 3 halves is 1.5. 5 halves is 2.5. Anyway, 3, we plug in 3. 3 plus 3 is 6. The absolute value of 6 is still positive 6. And half of 6 is 3. And then going in the other direction, -1. 3 plus -1 is the same thing as 3 minus 1, which is 2. And then that's the absolute value of 3 minus 1 is 2. Absolute value of 2 is still 2. 2 times 1/2 is 1. And then -2. -2 times -2 plus 3 is 3 minus 2, which is 1. 1 times 1/2 is 1/2. And then -3 plus 3 is 0. 0 times 1/2 is still 0. So 0. And then -4. -4 plus 3 is -1. And then absolute value of -1 is +1. So the absolute value, and then half of +1 is 1/2. And then for -5, that's -5 plus 3, so that's -2. Absolute value of -2 is +2. 1/2 times +2 is 1. And notice here, for instance, if we focus on 0, where x equals 0, y equals 3 halves, and then we go down 1 notch to 1, when x equals 1, y equals 2, and if we go back 1 notch, when x equals -1, y equals +1. So we don't have a pattern, because on the other side there is a kind of a natural pivot point where we can discern, extrapolate what the next number will be, because there's a pattern on both sides of said pivot point. But at -3, when x equals -3, y equals 0, and if we go back or go forward, when x equals -2, y equals 1/2, and then go back to -4, when x equals -4, y equals 1/2. So these two equal each other. When x equals 0, when x equals -1, y equals +1. When x equals -5, y equals +1. And you could bet that if y is 3 halves when x is 0, when x equals -6, y would also be 3 halves. So even if that's not on our table, Negative 6 plus 3 is negative 3, absolute value of negative 3. It's just positive 3. 3 times 1/2 is 3/2. So yeah, that would make sense. So the point being is this pivot point, that's our vertex. So at negative 3, 0 is our vertex. So we can go back on the x-axis to -1, -2, -3 over here. And we know that it's going to go up this way and up this way. I'm going to move to the right and go up. I'm going to jump to our y-intercept, which would be when x equals 0. What is y? When x equals 0 on this thing, y equals 3/2, which is 1.5. So we know that it's roughly over here, 1/2. So I'm just going to go like this. And similarly, sorry, the computer's not totally cooperating with me. So when x equals 0, y equals 3/2. And then we established when x equals -4, y equals 1/2. So that's roughly over here. And then when x equals -5 equals 1. -3. Okay, so I don't want to belabor this too much, but we see that it makes our little V shape. And we can also see that there's no restriction on what we can put in for our x values. So x is all real numbers. And so far as the range, well, the range, as low as we can possibly go, is at y equals 0. And it does equal 0. So I'm going to use a bracket. And it can go all the way up to positive infinity. But of course, positive infinity is aspirational. We never actually get there. So that's in parentheses. X-intercept would be where we cross the x-axis. So we touch the x-axis at x equals -3. So x equals -3. Y-intercept when x equals 0, y equals 3/2. So 1.5 or 3/2, same thing. There's no asymptote, meaning that there's not some line that we approach vertical or horizontal line but never quite reach it. Increasing, well, between x equals -3 and up, we keep going up in value. So I can say that between -3 and infinity, that's positive infinity. You do not need to put a positive sign there, but you can if you want. Between -3 and infinity, it's increasing. As far as decreasing, well, going all in the other direction towards negative infinity, where you do want to put a negative sign. Each subsequent value of x corresponds to a lower output, or y, up until -3. And then that completes problem number 8. Problem number 9 is really just y equals 5. The domain is all real numbers because you can have anything along the spectrum, the axis, plug in anything, and it's just going to be y equals 5 no matter what. The range is y equals 5. Y cannot be any other value than y equals 5. So that's the range. Vertex, there is none. There's just one horizontal line. There's not some line meeting that line. And then for x-intercept, this thing never touches the x-axis down here, so there is none. Y-intercept, yeah, x equals 0, y equals 5, so y equals 5 again. Asymptote, there is none. Increasing, this thing is never increasing, it's just a flat line, and it's never decreasing, so none. And that's all there is.